Hello, this is Mr. McGovern. This is the sixth video in the Electromagnetism series where we're looking at the force on a charge in a magnetic field. So I've got a horseshoe magnet here, and this is the magnetic field it has. It points from north to south. And if I place an electron in the middle of that field, the question is, which way is the force on the electron? Now, mistakenly, a lot of students will say, oh, it heads towards the north side because opposites attract. It's a negative and it goes towards the north. That's not true. Okay, this is a magnetic field and this is an electric charge. They're different things. So the electron's stationary and there's no force. The only way there's a force is if the electron is moving. If this was an electric field, not a magnetic field, then yes, the electron will be attracted to the positive side, but it's a magnetic field. We need it to be moving first. So let's say our electron is moving, right? We know an electron, a moving electron generates a magnetic field, and we can use our left hand to do that. So we place our left hand with a thumb pointing towards that arrow, and we work out the field around the electron, and above the electron, its dots, it's coming towards me. It's a circular field that goes right around that arrow and then crosses into the page below it. Now I'm looking for opposites, always I'm looking for opposites. And the external field is downwards arrows. What's opposite downwards arrows? Upwards arrows, and I don't have those. So now I have to think about the field in front of the electron and behind the electron. So think about the full circle going around. So I get my hand again and I'm imagining in front and behind. So in front, my fingers are pointing downwards, and if I curl my hand right around behind, my fingers are pointing upwards. And upwards is the opposite. So opposite the downwards external field is my upwards arrow. Where is my upwards arrow? It's behind the electron or into the page, and that's the force on the electron, into the page. This is the same process as with the wire, but we're just doing it for a single electron. So that's a bit counterintuitive, right? Instead of being attracted towards the north or attracted towards the south, it goes into the page. So there's a formula to work out the size of the force. We've worked out the direction. The size of the force is force equals BQV, where F is the force that we work out. B is the strength of the magnetic field in Tesla. Q is the size of the charge. So if we've got an electron, the size of an electric charge is 1.6 by 10 to the minus 19. Or we could have some other charge. And V is the velocity of the charge. Really important. As always in this topic, all the three things must be perpendicular, 90 degrees to each other, in order to generate the force.